Lesson 8.5 is constructing a function to model a linear relationship. So we're going to write linear function rules using initial values. At time t is equal to 0, a bicyclist begins riding at a constant rate of speed. 10 minutes later, the bicyclist has traveled 2.5 miles. Write the linear function rule that models the distance d that the bicyclist has traveled after any number of t minutes. Alright, so first what we have to do in order to write a function rule in the form y equals mx plus b is we have to figure out what the y-intercept is and what the slope is. So the first thing we're going to do is figure out what the slope is, the rise over run. So from his initial point to 10 minutes later, he has traveled 2.5 miles. We've got to figure out what that slope is. So we go up 2.5 and we run 10. So that's 2.5 over 10, which simplifies to the slope is equal to 0.25. Alright, so we know that the slope is 0.25. So the first part of our function is going to be y is equal to 0.25x plus. Now we got to figure out what the y-intercept was. Well, where did the bicyclist start? He started at 0. He had not traveled any distance when he started. So the y-intercept is 0. So we've got to figure out, I used y equals mx plus b just because that's the standard equation and that's what I'm typically using. But here we're asked to write this equation in distance d and time t. So here d represents the y-axis, so it's going to be d is equal to 0.5 and t represents the x values. So the linear function rule that models the distance the bicycle has traveled is d is equal to 0.25 times t. Alright. Sometimes you may be given 2 points and you need to write a function equation from these 2 points. So if we have the points, if we're given -4, 2, we graph those here, and 3, 12, we graph that here. We're going to use the values that we know for m and one of the points to determine b in the equation y equals mx plus b. Okay, so first we have to find the rate of change. So here we know that the slope is rise, how far did we go up, over run. And so from -2 to 12, we went up 14, right? 2, 4, 6, 8, 10, 12, 14. So our rise is 14 over our run, and these units are in increments of 1. So I go 1, 2, 3, 4, 5, 6, 7. So my slope is 2. Okay? Now I'm going to use 2 and one of these points, and I'm going to use 3, 12 just because they're both positive. So I'm going to plug this into y equals mx plus b. Alright, I'm going to use the point 3, 12. So 3 is x, y is 12. So this is going to be 12 is equal to m is 2, x is 3, plus b. Now this is how I'm going to find my y-intercept. I'm going to solve this equation for b. So this is going to be 12 is equal to 6 plus b, subtract 6, and I get 6 is equal to b. So now I know my slope is 2 and my y-intercept is 6, so I can write my equation in y equals mx plus b form. Y is equal to, slope is 2, x plus 6. And that's my linear function for that equation given 2 points on the line. Alright, so that's how you construct a function to model a linear relationship for lesson 8.5.